Vanakkam, Namaste, Namaskar. Welcome back to Jal Prayag. I'm going to take today a new topic. I'm breaking down from the sequence of the earlier topic of marine insurance. I'm shifting to a topic which is very basic and very regularly used on board, and that is how you manage your ship's time, which is called your ship's local time or ship's mean time, whatever you want to call it, but the ship's time which you adjust in your clocks, ship's clocks, as and when you keep moving to different places around the globe. So that is the topic I'm going to take. Now, I had a choice to make just a couple of slides, maybe 5 or 6 slides. I could have finished this topic. But this topic itself was suggested by my student, and then when I asked them before I started making, I told, should I make a detailed one with the pre-C boys, DNS and the BSc boys in view, or should I take just a small couple of slides topic, keeping you in picture? And the majority suggested that let me make a complete one. And those people who are first timers, who have not got involved into changing of the times on board, it'll be easy for them to understand on what concept, on what logic people do the change. But at the same time, those people who are already sailing, they have a choice. You guys can fast forward wherever you feel it is something you already know, and then you can go only to those slides which help you. It's both ways. But I suggest the first time you see, it's better for you to see the full one. And later on, if you have any doubts, you can always go back to those particular slides. This way, it is going to brush up and maybe remove a little bit of doubts and queries which you earlier had. So let me start with the topic, and I've titled it with a name called Times of Change. If you honestly ask me, it is a misnomer or misnamer, whatever you want to call it in English. I deliberately changed it so that it's slightly different. That's it. But actually, the points what you are going to discuss is not times of change. Actually, it's change of times on board the ship when you are sailing from one place to another. That is what is actually the topic. So I thought I will give it a little bit skewed, or whatever you want to call it, a different name. Just for the sake of it, I didn't want to just stick on to the same old monotony. So I thought I'll give it a different name. That's it. Okay. So let us go into this discussion about a change of times on board. As I said, I have made this keeping more in view of the BSc boys and the DNS candidates. So I'll just go with the basics also. We all know that different countries in the world do not keep the same local time. That is a fact. So when a ship sails from one place to another, one port to another, she has to synchronize its time with that particular country around which it is sailing. What are the reasons? Twofold reasons are there. You might be arriving at that port. So obviously your ship's local time and the country's local time or the port's local time should be same for you to keep the logs and all the records at the same synchronized with the same timings. And furthermore, there's one more reason why, because if you don't keep your local time as per the geographical location, your sunrise and sunset times are going to be a big issue, because either it would have been postponed or preponed a lot, which doesn't make sense also. So it is always wise to keep it synchronized with the local. Okay. Now, what do we do? So when the ship sails, we keep adjusting her time as per the area. But more than the area, I should say, as per the longitude. So let us see why the time is related to the longitude. Let us quickly do it with a small picture. We'll understand why it is done. As I said, this is a very basic topic, and all the sailors who are already there, and particularly the second mates who are involved in giving ETAs, they're all used to this. But even today, this topic is liable. That means the people are liable to do silly mistakes. It may not be a deliberate one, but just an oversight, a small miscalculation, a misunderstanding. So that is the whole reason why I made this video, because you should not end up in giving a complete different time or a date on your ETS, and that could be embarrassing. And I won't limit this to only the junior ranks. I've come across cases where even senior ranked people also can do these mistakes. As I said, it is silly one, but yes, you should not be doing it. So I hope this will help you in clarifying those doubts. Let us quickly look at the Earth. Why? Because I have to relate this whole time equation with the longitude. So I'm just giving you a globe with the North Pole and South Pole. And the line joining North Pole and South Pole is called the axis of the Earth. I'm not talking about the tilt of the axis and all those features. We'll do it later. But here it is basically the time. So uh, I have an axis, and we all know the Earth rotates about its axis. Okay. And you can call it that direction as easterly also. That is the way Earth rotates. And please remember, all the timings of day and night, everything is related to the sun. Sun is a fixed star which is quite far away from us, and that is fixed, it is not moving. So our daytime, noon, sunset, sunrise, everything, all the times are related to the sun. And since the Earth rotates, so every minute the longitude which faces the sun also keeps changing. So that is the whole idea of longitude being the reference for time. I'm going to give you one more. This left side picture was a side view. I'm going to give you a polar view. That means you're looking from the space, and you're looking at the North Pole, and you will see the same Earth is rotating like this. So here also it's very evident that as the Earth rotates, the longitude which faces the sun keeps changing. That is always moving. It's not constant. Okay. Now, somebody had to give a reference, any measurements or any timings needs a zero reference. So the modern day world thought, let us keep the Greenwich in UK, or Greenwich, whatever is the pronunciation, as a reference longitude to start the times. So, and the longitudes also, the measurements of longitudes, obviously. So it is called actually the zero longitude of the Earth. Now, this became a reference for time as well as a longitude. So it was given a name called Greenwich Mean Time, the time which is maintained at that particular longitude, or in modern terms, it is more called as UTC, or Universal Coordinated Time. So it's more common to use the word UTC rather than GMT. So let us also use UTC. Rest of the world's time can be related to this reference point, and since the countries keep different countries keep different time, it's difficult to remember. But if you know what is the relation with UTC, it is very easy. So that is why it is always related to UTC. Okay. Uh, at your home, we all know that we talk to our friends or family somewhere who is in foreign countries, and they always have different time than yours. It all depends whether he was west of you or he was east of you. So if he was west of you, his time will be behind yours, and if he's east of you, his local time will be ahead of yours. Now I'm going to show you a quick picture. Let us quickly look at a few of the reference points. I'll start with the Greenwich meridian, which is your zero longitude. You can see a mark that I know that longitude is shown as curved towards the poles, but you can realize it is mentioned as Greenwich meridian and is 0 degree longitude. I have referenced India also. So, and then I have referenced one more important feature, which is your international date line. I'll be talking about ID a little bit later. So this picture, let us say you are calling from India. If you are calling someone, in Australia, you will see he's ahead of your time. And if you call someone in Europe, he's behind your time. And this is what exactly I mentioned with example of Singapore. And let us say Europe. This is exactly the same thing which I have shown you in the previous slide also. Now let us look how the change of time happens. If you look at the rotation of the Earth, it takes around 24 hours to complete one rotation, which is called 360 degrees. So, quick question for you. So, how much turning does the Earth do in 1 hour? So, you will realize it does 15 degrees. So, it does 15 degrees of rotation, which also means that in 1 hour, the Earth rotates 15 degrees. Now I can relate this to time also. Why? Because the time, as I said, is related to the longitude, which is particularly facing the sun. So if someone has moved for 1 hour, that is 15 degrees, obviously the time has to change. Okay, let us quickly see one picture before I go into a little bit more detail. I'm showing you, this is a rough sketch, and I know the longitudes here are mentioned at 20 degrees, but doesn't matter, it's pictorial. The ship can move from, let us say, Greenwich meridian. She can go easterly like this, or she can go westerly also like this. It can do any direction. Now, as I told, I'm going to relate this longitude into time. So we saw for 1 hour, in 1 hour, the change of longitude is 15 degrees. So obviously, whenever a ship moves around 15 degrees away from its previous position, whatever time it was, I don't. So it is just an example. A ship moves about 15 degrees from its original longitude, then it is due for a change of clock by 1 hour. Now, whether you have to do plus or minus, we will see that, but it needs a change of clock. Okay, it depends whether your ship is sailing easterly or westerly. A simple rule for you is if you sail easterly, you keep adding your time for every change of 15 degrees. You will change your clock also by 1 hour and you will add it. Exactly opposite is if you are sailing west, I have to negate the time. Okay. Now it is always easy to have a round figure of 1 hour every 15 degrees, but that is not always possible. You will see different countries will try to keep different time based on their particular geographical location. One good example is India. India is not exactly at that 5 hours or 6 hours longitudes. It's somewhere in between. So it has got a east-west stretch of land also. So our country decided that we'll keep 5 hours 30 minutes away from the UTC. And if you look at the logic, we are on the eastern longitude. So we are 5 hours 30 minutes ahead of the UTC, which is on your Greenwich meridian. So this is a simple example for you. Okay. Now I'm going to show you how different ships at different places at the same time, at the same instant, let us say at the same instant, how they will be keeping their time. I'm giving you one ship, doesn't matter which direction it is moving, it doesn't matter whether it's moving easterly or, but at this uh, location, if you see, I have put the vessel on the zero meridian, and let us say right now it is midnight, so I'll call it 00 hours. Now, exactly at the same time, let us say there was one more vessel which was 15 degree away on the east to this particular vessel. Doesn't matter which direction is moving. He would have kept at 1 o'clock. And similarly, one more vessel, again 15 degrees, let us say east. He will keep 2 o'clock. Similarly, 3, similarly, 4. Please remember, don't bother about the direction you are moving. It is based on the longitude at which you are, the closest longitude of 15 degrees. So I've just given you a simple feature how at the same instant, these 5 different ships are at 5 different longitudes, let us say 15 degrees apart, and each one of them is having its own local time. So this is how it goes. And let me just give you one more example. Let us say one vessel was far east near Australia, even east of Australia also. And let us say the time, ship's time was 11 o'clock here. And again, our original vessel, which was at the Greenwich meridian, zero meridian, is zero. So if there was one more vessel just west of them, 15 degrees, let us say, it'll be keeping 10 o'clock. They should be keeping 9 o'clock, 8 o'clock, and 7 o'clock, and so on. Okay. This is how ships have to keep their times at different longitudes, particularly at a round figure of 15 degrees. That is a reference. So slight variations will be here and there. That is a different issue, but this is how it works. Please remember, adding your time, ship's time, whenever you are moving away from one place to another is called advancing your ship's clocks, and negating is called retarding your ship's clock. So what do you do? When do you do adding? Whenever you are sailing easterly, approximately every 15 degrees change in longitude, please advance your clocks by 1 hour. Exactly opposite, sailing westerly, approximate change of 15 degrees of longitude, please retard your clocks by 1 hour. I'm going to show you this in picture. Let us quickly look at this. Initially, I'm going to just divide the Earth into two, or Western Hemisphere and Eastern Hemisphere. You can see I'm going to reference with this violet color as the zero meridian. And all these places are called Western longitudes or Western Hemisphere. All these places are called Eastern longitudes or Eastern Hemisphere. You will see all the local times in this region of Eastern Hemisphere will be ahead of your Greenwich or UTC. Similarly, all this will be behind the UTC. So this is how the local times you will see will be distributed. I'm going to show you one more picture where different places will keep different zones of times. So let me just quickly show you. And a lot of similarity you will find in the color, but please remember, just please see here, I've shown you the first arrow near this Australia. This particular country is maybe keeping the same time as this Australia. I can see it is written as +8, but not necessary. It is not necessary. People can choose their own convenience also. Some countries do it. I'll give you one example of this a little bit later. Let me just show you next one. Okay, let us go near India. You see those places which are marked green, they will try to keep the times approximately similar. They may not be same, please remember, because we keep a very odd time, which is 5.5 hours. Now let us look near Africa. All these yellow colored countries might be keeping the same time as each other. And let us look at this Western South America and the northern part of Eastern US and Canada. You'll see this is the time. I'll give you one small exception. I'm moving my cursor. Please see here. Your Singapore is somewhere here. I'm showing you with my cursor, Singapore. Your Singapore is more closer to Indonesia and obviously Malaysia and all those places which normally are keeping 7 hours from your GMT or UTC. But Singapore chose to keep more matching with actually Hong Kong and Macau. The reason being Hong Kong and Macau and Singapore all were controlled by British, so they wanted to have a similar time. So they chose to keep Singapore also at your 8 hours. Your Macau and Hong Kong also keep 8 hours. You can see a little bit is Thailand and all those things. Okay, Malaysia, I'm sorry, Malaysia is also keeping around 8 hours. So you can see this Thailand and other countries are keeping 7. Indonesia is keeping 7. So this kind of disparity will be there around the same longitude also. Okay, it'll be there. So that is the country's choice. They want to keep it to their preference and they have the right to do it. So that is how the timing goes on. You can find such disparity even here also in this yellow color box. you can see not all countries are marked yellow. There are some exceptions. So this is for example only. Please remember, this is purely for example, just to tell you that my country can choose a particular time, which I feel is more comfortable. Now, this is what I had mentioned in the last slide. If you move easterly, doesn't matter from where you are moving, doesn't matter. You can move from US to UK, or you can move from Africa to Asia, doesn't matter where you're moving. If you move easterly, please keep advancing your ship's clocks by 1 hour for every 15 degrees. And exactly is the reverse. If you move westerly, doesn't matter where you move from. You can move from Korea, you can come to India, or from India, you can go to Europe. From Europe, you can go to US, doesn't matter. As far as you are moving westerly, please keep retarding 1 hour for approximately every 15 degrees. This is important for you. Okay. Now, we have been talking more about referencing ourselves with the Greenwich meridian, which is more of UTC. But please remember, there's one more important meridian in the world, and that is also something which can create silly mistakes. That is where the silly mistakes happen. And that is called your 180-degree longitude, which is also called as international dateline. So the name itself, ideal, tells you there's something to do with a date. So with advancing and retarding of ship's clocks, we'll have to think about changing the date also. And when does that happen? That happens when I cross the ideal. So this is where a lot of silly mistakes happen. So I'm going to show you possibly in an easy way so that you can make out. So I've changed the title at dates of change, basically actually change of dates. So again, let us look at ideal. What is ideal? I'm going to show you this picture. And I'm going to mark this with a red color, which you can see is somewhere around your 180 degrees. So there's a reason for me to make this red color a little bit bigger and wider, because you have a longitude called 180 degrees, but your dateline is not exactly 180 degrees. Since I'm looking at exactly opposite part of the Earth when compared to the 0-degree meridian, you are exactly opposite. You please see all of them will try to become opposite. Now, whatever you saw on the right side of that particular 0-degree meridian, it was called Eastern Hemisphere. But now you see here, you are in the opposite side of the Earth. So anything to your right is called your Western Hemisphere. Similarly, this is called Eastern Hemisphere. So it is a simple logic. Remember, Earth is round, so you are going to the opposite side and you are looking from the opposite side. So it has to change. Okay. So here in Eastern Hemisphere, all the times, local times are ahead of UTC, and here they are behind the UTC. So a little bit of imagination is needed. If I change this exactly same picture back towards my 0 meridian, it will be exactly opposite. Okay. So please think about it. Ideal is not a straight line as Greenwich. So let us just quickly look at a picture. Please remember, I'm not going on details about politically which country is coming here and there. No, just to tell you that it is not a straight line. Okay. So I'll show you one more picture, which is more closer to this islands, Pacific Islands. So some countries had allegiance towards US. So those people would have decided that we'll keep some other time, which is more matching to them. So this is how your ideal looks like. But as far as my concept is concerned, I'm going to make it a straight line. Whenever you cross that politically correct date line, please change your dates. So we'll see that. Okay. I'm going to quickly give you a polar view also, because polar view is always something you can never go wrong actually. Polar view. Again, looking from the space, I'm giving you this as a North Pole. Then I can see that one side of this North Pole, I can call it 0-degree meridian, and exactly opposite, I can call it ideal. So if you look from the North Pole, this is how it looks. And please remember, this portion of the Earth is called Eastern Hemisphere. I have marked with 001 to 179. just because the 0 and 180 exactly the longitudes, there's no need for you to mention east or west. They are kind of reference points. So you need not call it east or west. Similarly, on the Western Hemisphere, I marked as 001 to 179 west. So this is what you should remember. If you ever get confused, this polar diagram is always good for you to guide actually. Okay. Let us quickly look at two of them together. That means I'm going to place the Greenwich meridian or zero meridian. Then this is the ideal. Obviously, this is ideal. Why? Because it is a paper. You rotate it and make it circular. Both the red colors will meet. So basically, the red colors are exactly the same. Only thing is I have made it a flat piece of paper. That is ideal, and this is also ideal. And this is Greenwich. Now, let me take a small example. Let us say that right now it is midnight at the Greenwich meridian. It's midnight. Okay. If you try to go easterly, approximately around 45 degrees longitude, because 45 is 3 into 15. So you will see it is plus 3 hours. So 3 o'clock in the morning. Again, let us go easterly 45 degrees. So it is 6 o'clock in the morning. Again, 45 degrees, 9 o'clock. Again, 45 degrees, you will reach the ideal, which will be 12 o'clock noon. So please remember this. Let us go westerly now. Let us go westerly. Again, this again is a repeat. Your local time at exactly at the ideal on the eastern side of ideal, it will be plus 12 hours from UTC. There's a 12 hours difference when you go to 180 degrees. We already saw 24 hours is 360. So obviously 180 degrees is going to be 12 hours. Similarly, let us go western. If I go approximately 45 degrees on the western side on that same particular instant, some country was here. It is supposed to keep minus 3 hours, which is 2100, then 1800, then 1500, and then again 1200. Please remember this. So the local time exactly on the western longitudes, very close to the ideal, is going to be minus 12 hours. Now, please see this disparity. That means on the right-hand side, I'm plus 12 hours, and the left-hand side, I'm minus 12 hours, but they are going and meeting exactly at the same ideal. So that means places are 24 hours different just across the ideal. I'm going to give you more examples. Let me give you the example. Same picture, I removed that map I'm trying to show you. Let us consider right now, exactly at the Greenwich meridian, it is 25th February and midnight, which is 00 hours. Okay. So you all should agree, if I start moving easterly, and I just reach very close to the ideal, which is plus 12 hours, you should agree that it will be 25th February, 12 o'clock. And I've given you a longitude very close to the ideal, 17959 east. Similarly, let us start moving west now. If I move west, exactly, let us say 17959 west, it is minus 12 hours from the 0 degree longitude. So minus 12 hours, please remember, from midnight, minus 12 is the previous day's noon. So if you look at both the red color lines at the two extremes, both are noon timings, both are noon, but there's a change of date. So this is what is important. So let us see how it works. Okay. Now I've changed the picture. Please remember, here this picture was more Greenwich centric or zero meridian centric. Now I made this picture exactly opposite. I made it ideal centric. So I have shown you ideal, and then on both the sides I have the Greenwich meridian, which is your 0. Okay. I told you, whenever I shift from one picture to another, things will change. It will become exactly opposite. Now you can see what I had on my right side as plus 12 is on the left side, and exactly opposite. So this is where you should be careful. So then in that case, I'm going to take the same example, but I'm showing you with respect to your ideal. Please remember, Eastern Hemisphere, this is Western Hemisphere. This is 25th at 12 o'clock. This is 24th at 12 o'clock. This is where the confusion starts. Okay, please remember this one. Now I'm going to sail a ship and let us see how it works. Okay, so I've taken a same picture with a small map, exactly the same picture. I've given you the same dates. Whatever was there in the previous slide exactly is the same, 25th on the left and 24th on the right. Now, what happens if a vessel crosses when it is moving easterly? This direction easterly can never change. Doesn't matter whether you are at zero meridian or ideal. Easterly means it is easterly. I'm going towards east. That's it. If a ship moves easterly, let us say from Asia Pacific to the Americas, please retard 1 day. So the date should go 1 day before. Time is still 12 o'clock. Time, please don't change. Now, exactly similarly, what happens if a vessel moves this side from Americas to Asia Pacific? So from 24th, I have to jump to 25th. So that means if I move westerly from Americas to Asia, I have to advance 1 day. The date should become 24th to 25th. Time is still 12 o'clock. Please remember, time is still noon. Now I'm going to show you this as a complete gist of whatever we have done in the one last slide. I'm going to show you that. Please look at this. I'm still taking the date line, okay, as reference, because this is where the confusion starts. I mentioned the 24th and 25th February. Western longitudes, please remember 24th February noon. Eastern longitudes, it is 25th of February noon. Let me sail a ship. If I sail a ship on the easterly direction, number one, first thing I have to do is I have to advance my ship's clocks. Always advance my ship's clocks. But while I was advancing, if it crosses the ideal, please retard 1 date. Okay. Now let us look at the other case. My vessel, if it moves westerly, always retard your clocks by 1 hour every 15 degrees. But the moment it crosses ideal, I have to advance the date. So this is my final slide, which gives completely everything. So logically, this picture is good enough. But for those people who believe in thumb rules, I always say thumb rules should be always used secondary to cross-check your work. But nowadays, most of our students go on the thumb rules first, and the logic is somewhere lost. So that is why I'm giving you the thumb rule only at the last. If you move easterly, please keep advancing your clocks and at ideal retard. So it is advance and retard. So two different combinations. And if you move westerly, I'm sorry, there's a mistake on my spelling on retard. If you move westerly, please retard your clocks 1 hour every 15 degrees. And the moment you cross ideal, advance your date. So please look at this thumb rule. If I say moving easterly, advance clock and retard date. If I move westerly, retard clock and advance date. So two opposite. Okay. So that's the end of this particular presentation. I'm just keeping this picture again for a little while so that in case you want to completely come out of your confusion, it is there. So whenever you advance and you cross date line, you retard a date. Whenever you retard your clocks and cross date line, you will be advancing. So two opposite things you will be doing. So this is what is the whole principle or concept of changing the ship's clocks. I know it was a little bit big, but as I said, I went on the suggestions by the students. They said, let me make the full one. Those people who are first timers and who are weak in this concept, let them see the full thing. And those people who already are okay, it's just a brush up and a refresher for you. I hope this video was good enough, particularly for the beginners. That is what was my. I'll be making one more smaller video. Let me say I'll make it on daylight saving time and the time equation, how the equations are mentioned in the books and how you should use it. when you are trying to refer some books. I'll make a small video on that as a part 2. Well, till then, please keep watching Jal Prayag. Your suggestions are always welcome. This whole video came as a suggestion from the students only, because errors were being made by even senior staffs also, senior management levels also. So till then, uh, please hold on till I make the next video. Until then, Vanakkam, Namaste, Namaskar.